Hello everyone, welcome back. In this video, we are going to continue our conversation about exponential growth and decay. As you remember, in the previous video, we introduced these two models here. As you can see, they are very similar. The only difference is 1 plus r here and 1 minus the rate. So in this video, we are going to use two examples to practice how we use the growth or decay mode. Let's check the first one. When we deposit 5,000 into a saving account, you will receive 3% interest per year. How much money will you receive or have in your account after 12 years? So as you can see, this situation, when we see the interest word like that, meaning the value of the money actually increasing, so that means we will definitely use increasing mode. So this is a mode, sorry for that. This is a mode we are going to choose. Next, we just need to plug in the value based on this situation. So the A, meaning the starting point, as we can see here, is 5,000. So we just type 5,000 here. And then the R is a rate, which is 3%. But to use it, it's always a good way to convert it to decimal, which is in this case 0.03. What you can do is you can put the 3 divided by 100 to get this value, or you can just move the decimal point to the right, and you see here is 0.03. So it's 1 plus this decimal, and then over the time, which is 12 years, and that's it. So in order to find the answer, we are going to put everything here in the calculator. You can try to use your calculator to find the answer, but do not break it down. Do not do the parentheses, then figure out what I'm going to do next. The easier way to do this, just type everything in the calculator. So in this situation, I just type everything. And I even put a parenthesis, I see here, 0.03, same as 0.03, and then to the 12th power. So the final answer, as you can see, is very long decimal here, right? But as you can see here, the question asking us to round it to the nearest cents, meaning 2 decimals here. So we just need to check the third number 4. So we do not round it up, then this is going to be our answer. So we can write down is 7128.80. I will readdress this part again about rounding here. First of all, cents, for example, we have quarter, then this is 0.25. So cents meaning 2 decimals. And another part I want to remind you about each digit. So the first number here, 8, the first digit after the decimal point is tenth, hundredths, then thousandths. So for example, if we really need to keep the first 2 decimal, we just need to check the third one. If this is greater or equal to 5, you raise it up. If this is less than or equal to 4, then you just get rid of this. So it's like 5 or more, raise the score. 4 or less, let it rest. So this is a basic way to do this. So this is our final answer in this one. Okay, this is how we type everything in the calculator, we get the answer. Let's move on to the next. This one says if the population of the town is decreasing by 2.5% per year and the starting residence is this amount, then asking us the population after 10 years. Again, the key word here, decreasing, is indicating we have to choose decay mode. So we write down the mode and then we just plug in the value accordingly. For this case, we already know initial amount is 12,500 and then 1 minus. Again, the rate here is always a good idea to convert it to decimal. But do not forget, 2.5%, you move this decimal to the left. So you make a 0 here, so 0.025. So is 0.25. And T is a time, so is 10 years. Sorry for my handwriting. Again, it's always a good idea to just pop everything in the calculator. Just type everything. And then y minus 0.025 and over the 10 years. So, and then that's it. And also this answer asking us to find to the nearest whole number, meaning no decimal here. So this meaning no decimal. So we just need to check the digit after the decimal point, which is 1. We're not going to round it up, so it's gonna be 9,710 residents after 10 years. Another thing I want to remind you, this symbol here meaning approximate value. Because we run it up the answers, it's not accurate one. So that's why you kind of your score the equal sign here is approximate value here. Okay, so that's the example I want to share with you for modeling the real life situation with exponential function. As you can see, we can always choose a model based on the situation. I hope this video is helpful. Thank you so much for watching. See you soon, everyone.